Hey everyone, welcome to this lecture for P 105, a course on data science. This is the second in a collection of 2 videos that wraps up some additional thoughts on data wrangling. Last time we talked about reading data from the web, and today we're going to be talking about strings and factors. I'm going to start by giving an introduction using slides. After that, I'll demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful. To get the most out of this, please do code along with me. All the material is available at p105.com, and there are links in the description below. Awesome, let's get started. All right, we're going to be talking about strings and factors, and I think it's helpful to talk about both of these together because they look, when you're looking at a data set in R, they look very similar, and you might think that you're going to interact with them in the same way, but as we're about to find out, they are in fact very different from each other. They both, when you open up a data set that contains either a string or a factor, you're often going to be looking at things that look like words or phrases. But if you're dealing with a string variable or a character variable, you are really just looking at the characters. There is absolutely nothing else going on in the data set. You can often recognize a string or a character variable because there are quotes around the outside of things. Factors often don't have those things. But factors, beyond that, they often look very much like words or phrases that might describe something, but what R is doing behind the scenes is very different. Underneath the structure, or underneath that representation, R is storing those values as integers, 1, 2, 3, 4, that then have labels attached on top of those. And that makes a lot of sense for some things. If you're dealing with things like BMI categories or age categories that are defined as ranges with clear cut points, you might want to think about this as a 1, 2, 3, 4, 5. Same thing with like very bad, bad, okay, good, and very good. Often you're going to see those words, but underneath that, it's reasonable to have a integer structure that describes what's actually going on in the data set. Characters, strings, character variables make a lot of sense for things that where that structure just isn't reasonable. When you're getting free text input from survey respondents, or you're getting data from a website that's going to be looking at reviews or something like this, and even beyond that, I think things that come up more often in public health these days, things that have to do with like genetic information, genomic information. Often genes are coded in alphanumeric strings, and you don't really want to impose some underlying structure on those. In those cases, strings make an awful lot of sense. Character variables are the right thing to do. In other cases, factors actually work. So God, why does this get so complicated in R? And we'll, for a really deep dive into this, there is an article online, you can probably Google Strings and Factors by Roger Peng, and he goes into a lot of detail about this, but the short version is roughly the following, that when R was invented, you know, back in the mid-1700s or whatever, when R was invented, most of the data sets that folks who used R, that statisticians who used R worked with, really didn't have free character variables included. Most of the time in those cases, it made an awful lot of sense to encode anytime you saw something that looked like a string variable, to assume that that was going to be a factor variable. And beyond that, the assumption that you need to have that numeric structure, a 1, 2, 3, 4, underlying some categorical predictor, also makes sense from the perspective of building regression models. If you're going to do some regression analysis and you have a categorical predictor, you have to assign one of those to be a reference group and the other ones to not be the reference group. And so you need something behind the scenes that keeps track of what the actual order is here. It also shows up when you're making plots or you're making tables. That underlying factor structure makes a lot of sense for data sets that existed in the past. And as a result of that, R built in a variety of features that would assume that when you saw something that looked like a character, something that looked like a string, that it really was in fact a factor. So that existed for a very long time in base R and was built into things like read.csv and data.frame. Other things like that would assume that you were dealing with factors unless you were clear that that wasn't the case. Over time, more people started using R, and also the kinds of data sets that statisticians, biostatisticians, and other folks who used R in the past came into contact with, those data sets changed and people's preferences changed. And I'm not kidding about this. People wrote a package that would change R's underlying default behavior from assuming that things were factors to no, they're not factors. This is a badge that you could attach I'm not joking about this. You could take this badge and attach it to your conference name tag and wear it around at conferences if you felt really strongly about this. And I'm not joking about that, and I'm not going to tell you whether or not I had one of those myself or not. I guess I will point out this has changed a little bit with R 4.0. Finally, R said we're not going to build in this assumption moving forward, just sort of in response to a lot of this public outcry. All right, so you are often going to have to deal with string variables, with characters. I think the operations on strings come up frequently enough that it's helpful to know how they exist. Or know that they exist and how they work. But I don't imagine, depending on the kind of work that you do, you're not going to be spending a huge amount of time working with strings. It's helpful to know what they do, though. So if you have a couple of words that you would like to join into a phrase, you can do that using concatenation. If you have either a long phrase and you need to extract some subset, or you need to extract some particular word, you want to cut off at the beginning, you want to cut off at the end, whatever it is, that's a common operation. You might need to change the cases, everything from uppercase to lowercase or something like this. A very common one is replacing one string segment with another. You see some phrase and you want to replace it with another phrase. Or even more often, you see some phrase and you want to replace that with nothing. You just want to get rid of everything that looks like this particular word or phrase in a collection. Most of the operations, I think the vast majority of the operations that you're going to run into, the stringr package or stringr package is a really good way of dealing with these operations. Where strings get complicated is in cases where you're not looking at a specific word, you don't know exactly what it is you're looking for, but you're trying to match a pattern. And in that case, where you're not sort of saying, I need to match everything that has these 4 letters in this order, if you know, like, I need to find something that looks kind of like this, well, you can do that, and you can do that using strings, but encoding a pattern is substantially harder, or at least quite a bit harder, than just sort of knowing this is exactly the thing that I want to match. And so we will talk a little bit about regular expressions and how you might use them, but if you find yourself having to deal with regular expressions, that's a tough thing. I think there's a quote that sort of floats around that says, you know, if you have a problem and you think regular expressions are the solution, now you have 2 problems. You still got your first problem, and now you have a regular expressions problem. So congratulations, that's going to be a tough thing to do. But it is, again, these are helpful things to sort of know how they exist and how they work. All right, so separately from strings, you also need to know how to deal with factors. And the reason that it's important to know how to deal with factors is because some of the operations that you're going to do in statistical analysis or in communicating effectively rely on understanding what's going on with a factor. And in particular, if you need to know, here are my categories and there's an underlying 1, 2, 3, 4, and you need to change in some way what the first entry is. You want this group, the thing that had been number 3, you want that to appear first. Well, you sort of have to know that there are labels, and underlying those, there is some numeric representation. And you might need to change that ordering because you want to have a different reference group in some model that you're building. You might want to have output that's structured a little bit differently. You might need to expand the number of levels or collapse the number of levels so that the categories actually represent the things that you're interested in. So there are a variety of common applications, or sorry, common factor operations here. Converting first something that had been a character to a factor. Sometimes that happens implicitly, but you should know exactly what's going on. You might need to change the levels, the numeric representation that is under the labels that you're looking at. You might want to move one thing specifically. You might want to see, well, which one of these happens the most frequently in my data, and I want that to be the most important. You might want to say, I want to put these in order according to some other variable in my data set. I want to put the BMI factors in order according to age, or I might want to put good, very good, something else in order according to like some number that exists somewhere else in your survey, right? Those are the kinds of things that can come up. You can change those labels. You can drop labels that you're not using. In a lot of these cases, the functions that you're going to be using come from the forcats package, which is also included like stringr in the tidyverse. And just so that you know this is something that I know and I think everybody should know. Forcats is a play on words in at least two ways. It's forcats because it's four categorical variables. It also is an anagram of factors, and then since people in R like cats, I guess it's also sort of for cats in that sense. And if you don't believe me that people like cats, here are two other cat-related stickers that are coming from the tidyverse and tidyverse adjacent in the R community. So fantastic. Okay, what we're going to do now is switch over to a screencast and see how strings and factors work in practice. All right, so what do we got going on? I have opened up RStudio. I've opened up the R project that corresponds to the two videos that we're working with. I've also gone ahead and before starting to record this video, created a strings and factors R markdown file that is right here. It's strings and factors, it's a GitHub document. Most of the stuff at the beginning, all the stuff at the beginning, looks the same as many of the documents that we've seen in the past. We are going to look at a couple of examples coming from the P8105 datasets package, and we're also going to take a look at some data that come from the web using the rvist package. The other stuff here is about the same. Now I've started out here at the beginning. I've created a variety of string vectors here, and I'll talk a little bit more about these as we go through. All of these are available on the course website at p8105.com. You can copy and paste them yourself. My goal for right now is not to spend a bunch of time typing out strings, but to start seeing how we might actually manipulate or use regular expressions in the context of strings. Now I've also here making a choice to create string vectors, right? These are vectors that are going to be things that exist as just sort of like 3 or 4 observations. They're not inside of a data frame. They're not columns in a data set. But I think that this is a useful way, at the very least, to get started thinking about string operations without sort of worrying about how things exist inside of data frames. When you start worrying about data frames, there's not a whole lot of extra stuff that you have to do, but these string operations often exist either inside of a mutate statement or they exist in some way where you're filtering a data set. And for now, I really just want to focus on pattern detection and regular expressions when operating on string vectors. So that's what we're going to do here. So again, you can either type these or even better copy and paste them from the strings and factors page on P8105. And what I'm going to be talking about is strings and regex or regular expressions. So my first string vector, let's just sort of take a quick look at, has 4 elements. And those 4 elements are my name is Jeff and everything is lowercase here. And what I'm going to start out talking about are the kinds of things that exist in the stringr package. And so here I'm going to see, is it possible, for example, to identify the element of this string that corresponds to my name? And so what I want to do here is detect a particular pattern. And the way I'm going to use this is with str detect. Okay, and first I'll open up the help file here just to make sure I know what's going on. Oh, I haven't loaded any of the packages or anything yet. I wonder nothing works. All right, so let's take another look. Let's try that again. Okay, so str detect detects the presence or absence of a pattern in a string. So you can do negate if you need to. That's not something I use too often. But basically what we're going to do is say, given a string or a vector of character observations, can I detect a particular pattern? Does this exist in my string? Okay, so let's take a look at str detect on my string vector. And the pattern that I want to detect, this is an easy pattern. I am just going to look exactly for a word. I am going to use my own name, Jeff, and here it says there are 4 patterns, or sorry, there are 4 observations here, and I am seeing that it doesn't detect that string in the first one, it doesn't detect that string in the second one, it doesn't detect it in the third one, it does detect that string in the last one. All right, so it is giving me a false, 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 and true. I could also check, does it detect just the string Jeff? It doesn't have to match everything. Can I detect, does it detect just J? Yes. If I want to see, does it detect an E? It's going to say yes now twice because it detects an E here and it detects an E here, right? So when we're detecting this pattern, I'm not saying that it has to match the entire string observation, the entire the entire string observation doesn't have to match that pattern exactly. It's just asking, does this pattern appear anywhere in this collection of characters, right? So that's why E is giving me a false, true, false, true. If I did JE, it would give me false, 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 true. And if I did, let's see something a little bit different. If I did a capital JEFF, it's going to give me all false. And the reason it's giving me all false here is that if you're working with strings, uppercase and lowercase are different values. And if you want to detect a string, you have to get that pattern exactly right. So here, none of these actually match an uppercase JEFF. All right, so what if, though, I wanted to do something that's a little bit different, where I said, I feel strongly that my name should be capitalized. Is there a way that I can modify that string vector to replace one character or one string with another string? And yes, there is. So I'm going to be using, instead of str detect, I'm going to use str replace. And I want to replace in my string vector the pattern that I detected, JEFF, with the replacement that I care about, capital JEFF. And now it's giving me a new string. Again, I'm not asking true or false, did this detect an observation? I am updating a particular value. So here I'm getting my name is capital JEFF. And that, I think, is pretty fantastic. Okay, so we can detect some things and we can replace some things. And if I sort of just left this with a lowercase j, and then I replaced all of that with Jeff, I would get some weird stuff, right? You do have to be a little bit careful when you are replacing or detecting a pattern. I could also get rid of everything if I wanted to detect Jeff and replace that entirely. Now I've got something empty, right? You can detect and replace things, and I think that's a useful thing. That comes up a fair bit. So now I've got a new string vector. I think we all rule for participating. I think I've been caught. I think this will be fun. It will be fun, I think. So let's see different ways that we might detect in my new string vector. See if we can detect, I think. So here, that phrase does show up. I think that pattern shows up in all of the different things that I'm interested in, so I get 4 trues. Now, this is sort of the first place that I'm going to introduce regular expressions. And the way that I'm going to introduce this is by saying, let's take the string that I want to match and see if we can be more specific about where that match comes. So can I, for example, say, I want to detect strings that start with I think, but not end with I think. And so here, the thing that I'm going to use in the context of this regular expression is, this is the pattern that I'd like to detect, and I'm going to be a little bit more specific that that pattern, I'm putting a caret here at the beginning, this string, this is the beginning of the line that I'm interested in, so I want to detect beginning of the line and then I think. So here, if I run this, I get true, 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 and false, because this is not happening at the very beginning of that line. It's not happening at the beginning of this observation. What if I wanted to do the reverse? I want to detect something that ends with I think rather than begins with I think. Well, I'm going to close with a $sign here and get false, 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 and then true. So that's working out for me. Now, this again, I think is helpful as a way to start getting a sense of what regular expressions do. Regular expressions are a combination of either rules that you're interested in, starts with or ends with, and then some text pattern that you would like to match. And you can make these combinations even a little bit more complicated. So let's take a look at this. Y'all remember President H.W. Bush. I saw a green bush, barbecue and bushwalking at Molonglo Gorge, which is, I had to look this up, this is a place in Australia. And then for folks who remember alternative music in like the 90s, Bush live and in concert. I had to admit, I borrowed a lot of these string examples from Jeff Leake. Jeff Leake is a faculty member and data scientist in biostatistics at Johns Hopkins University. So actually, I don't know, I might have to ask if he actually went for barbecue and bushwalking at the gorge. I don't know. Anyways, so what I want to do here is see, first, let's try to detect str detect, come on now, in my new string vector, sure this is my new string vector. Let's try to detect, well, what if I just typed lowercase bush? I get a true here because I did see a green bush. What if I did an uppercase and tried to get, say, George W. Bush, sorry, H.W. Bush, and Bush walking? I should get a true, false, that works. What if I wanted to get all three of these though? What if I wanted capital B or lowercase b? Well, that's going to give me a little bit of a problem. I guess I could do like string detect this or string detect that and try to merge those two things together. What I'm going to use though is a regular expression that gives me some options here. So if I put a bracket around this and I give it both a capital B and a lowercase b, that says in this pattern you can match either this character or this character. Either one works as long as the remaining three characters are USH all lowercase. So this is going to give me true because that pattern matches capital B, lowercase b, capital B, and this doesn't match because the remaining characters don't match either. Right? So we're starting to get something a little bit more complicated here, and we can make that even a little bit stranger. So let's take a look here at my next collection. I have the 7th inning stretch. First half is about to begin. Texas won the toss. She's 5 feet 4 inches tall, and it's 3 a.m. I can't sleep. Frowny face. Okay, so what if I wanted to detect here things that look like the following? I want to be able to get a number first, followed immediately by a letter. So a number first, 7 followed immediately by a letter, T, number first, 1 followed immediately by S. This isn't going to count because I've got a 5 and then a space and a 4 and then a space. I don't have a number followed immediately by a letter, and then 3 a.m. Hopefully that'll work also. So again, I don't really want to be able to say str detect in my string vector. I really don't want to worry about having to list out 1 or 2 or 3 or 4 or 5 or 6 or 7, but the same process is going to work for me here. So I'm going to have a bracket, and I need to define what letters or numbers are allowed in here. And again, I don't want 1, 2, 3, 4, 5, 6, 7. So I'm going to use here anything between 0 and 9, right? Anything between 0 and 9 is going to work for me. And then the next character, instead of saying I want A, B, C, D, E, F, right, whatever, that would take forever. So I'm just going to specify the next one can be A to Z, that range, and I'm even going to get capital letters. I'm going to go capital A to capital Z, right? Both of those are going to work, and let's see what happens here. So I get a true, true, false, true. That works. And I could be a little bit more specific here that I want this to happen at the very beginning of a line, and it's not going to change any of my results here. Things are going to work the way that I need them to. Okay. All right. So what are we going to take a look at next? Here I've got strings 7:11, 7-11, and 7.11, and then I have a 711 floating around in there, and I want to construct something that catches this, this, and this, and then misses this one. And to do that, I'm going to introduce str detect string vec. Ooh, that's the wrong way. String vec here. Let's make sure this is my string vector. What I'm going to detect here, I'm going to use 7, and then instead of trying to construct something with these brackets to capture characters that exist here in the middle, I'm going to use a special character called a dot, right? I'm going to use 7.11, and you might, this is where regular expressions start getting weird, you might think to yourself, this ought to capture just this, but dot, sort of like the caret was a special signal in regular expressions that says it needs to start, and a $sign is a special character that says it needs to end. In regular expressions, this dot is a special character that actually is going to match literally anything. It's going to match any other thing that might exist in a string. So if I use this dot, I should get a true and a false, because this doesn't match 7, another character, and then 1, 1. This does. Hopefully this will all work for me. And yeah, I get true, true, false, true, and that's looking okay to me. Now again, this dot is a special character in regular expressions, and as I've said, this is where things start to get a little bit strange. So if I wanted to match a dot specifically, I have to be a little bit more careful. I have to tell the regular expression that this is not intended to be a special character. This is intended to be an actual literal dot. And so the way that you tell a regular expression to interpret something, not as a special character, but as the thing that you're looking at, is to put a slash in there. And unfortunately, slash is also a protected thing. So if you want in a regular expression to have that slash be interpreted as an actual slash, that then telling this to be an actual dot, you have to put 2 slashes. So if I run this, now I'm actually saying I want an actual, legitimate, no joking around, an actual dot to be the actual character that I'm detecting here. I would use 7//.11 to detect only this and to not treat that dot as a special character. So let's take a look at another example of how this works. There are a variety of things that are interpreted as special characters here. So I've got in my new string, the confidence interval is bracket 2 to 5. I've got sort of a happy face and a frowny face, and then I found the answer on pages 6 to 7. So again, these square brackets and things like parentheses, things like slash, other sorts of things like that are special characters. So if I want to detect an open bracket, again, I want to detect that's an open bracket, that's an open bracket, and so is that. If I want to detect that open bracket, I have to be a little bit careful. So here, let's run this and do str detect in my string vector. And what I want to detect is open bracket, but it's a special character, so I have to use a slash. And of course, the slash is a special character, so I'm going to double slash that and get my open bracket and detect the thing that comes out of this. It's a lot. It's a lot to be concerned about in terms of what seems like it should be an easy operation. Understanding how to construct a regular expression to find a particular character or a particular pattern is not an easy thing to do. And that's sort of when, in the slides I mentioned, if you start finding yourself with a regular expression problem, very often you end up with 2 problems. You have whatever problem you're trying to solve, and also you have to figure out regular expressions. Now that said, it is helpful, again, to know that this exists so that if you find yourself in a scenario where you have to work with these things, then it's actually going to work. What I'm going to talk about next is factors really briefly. And what I'm going to do here with this factors is again, create a vector, and I'm going to try to illustrate how R is storing that vector and what kinds of operations we might want to use. But let's sort of take a look at this, right? So the vector that I'm going to create, this is a factor vector. Let's just do factor, and I'm going to construct this male, male, female, female. Okay, that is my factor vector. And if I just sort of take a quick look at this, it's giving me a little bit of information in a way that I think is different than the string vectors that we had seen previously, right? A string vector lists out all of the options that are available here, but it doesn't have any additional information about levels. It's not telling me anything about that. And all of the strings are appearing here in quotes. Those are a couple of things that can sometimes be a giveaway that I'm dealing with factors. Now, when I created this factor, I didn't say which one was the reference, which one should be assigned a 1, and which one should be assigned a 2. What's happening here is, given a collection, male, male, female, female, R has implemented some rule to determine what the level order are. And the levels here are female first and then male, because it's using alphabetical order in this case. Now, you can also double check what happens here. So if I used as numeric for my factor vector, what I'm going to end up with is a 2 and a 2 and a 1 and a 1. So it's taking my levels, male, male, female, female, and it's saying that really underlying this, this is a 1 and this is a 1, this is a 2 and this is a 2. And when I convert that factor to a numeric, I can actually see the integer structure that underlies the factor variable that I have created. Now, let's just sort of assume for a brief minute what happens if I re-level some of these. So I'm going to take my factor vector and I am going to update it using factor relevel. And here I'm going to relevel by hand. We'll talk a little bit more about this in just a second. I'm going to relevel that factor vector, and I'm going to make male the first category. So let me do that. And now I'm going to take the same 2 lines of code and run them again. So now the vector, in some sense, it doesn't look like it's changed, right? When I ran this line up above, I still got male, male, and female, female. But here what's happened is male is listed as the first level and female is listed as the second level. And if I convert this to numeric, we'll actually see this more clearly. Here, that factor relevel has switched things around. So instead of having male correspond to 2, now male corresponds to 1 and female corresponds to 2. This is, I mean, like, I guess there are a couple of points that I want to make here. First is that factors and this kind of infrastructure that exists for factors, the behind-the-scenes numeric coding of factors, is one of the things that I think is the most confusing about factors, because it is some element, it's something that exists in your data that R uses, but that is most of the time hidden from you except in implicit ways. Factors will show up in reference categories for linear regression, and factors will show up, the numeric elements of it will show up in plots when you want something organized according to a character observation, right? Factors exist and they matter, but a lot of times you don't really see exactly what's going on, right? So again, when I created this factor, R assumed alphabetical ordering mattered for the factor levels and made 2 male come after 1 female for that reason. Now, I am gonna, I guess, sort of point out here, I used factor relevel. So let me take a look at this real quick. What factor relevel does is take in some factor vector or character. It will force this to be a factor if you haven't already. And this gives you a way to factor levels by hand. And we're not gonna worry about defining this using a function. Either a function or character levels. So I'm using the second option here. I am just going to say, this is the level that I want first. You can say this is the level I want second. This is the level that I want third, and so on, right? So you can sort of use this factor relevel to move factors around by hand by just listing out what factors ought to come first and what factors ought to come second. Okay. Now when I did this question FCT, you'll notice there are actually a lot of things that exist here, right? So the forcats package, generally speaking, has structured the function names so that they all start FCT underscore something. So you get FCTC, some way of putting together factors, FCT drop, a way of dropping levels from a factor. You can do factor in frequency. We'll see that in just a couple of minutes. Some way of ordering factors according to the level. You can do in order, the order that they appear in a data set. In sequence, you can see also there are a variety of these that I think are useful. The ones that I use the most are factor relevel and factor recode. Factor recode lets you change a label. And then I use factor reorder an awful lot also. And so those, but there are, I guess, other functions in there that it's helpful to know that they exist. And while I'm on the subject, the stringr package has a very similar structure. So we used str_detect sort of a lot, but you can also use str_count, str_extract, str_locate, order, remove, things like this. There are a variety of useful string functions in here, and I'm pointing both of these out to you so that at some point, if you think, I really wish there was a factor function that did this thing, probably there is. Check out what's going on in the forcats package, or Google R forcats this operation, and hopefully there will be something that exists and you'll just have to figure out how to use that function. All right, so that's a fair bit of information about strings and also a fair bit of information about factors. And what I want to do next is just sort of revisit a couple of examples that we've seen in prior videos to get an idea of the kinds of things that are going on and how you might actually use these strings and factors. So what I need to do here, I'm actually going to go, actually before I do anything, I haven't knitted or committed in a while. What am I doing? All right, so strings and factors intros. Great. So what I actually want to spend a little bit more time on today, I'm gonna go quickly back to revisiting some data set, and I'm gonna copy this URL. I'll talk more about this in just a second, and then I'm going to take this code from the video that we did on reading data from the web. All right, so the data set that I'm looking at here is the National Survey on Drug Use and Health, and we spent some time in the last lecture looking at Table 1, importing Table 1 and trying to make sure that we were able to extract all of this information. And so when I copied over the URL here and this code, that's sort of the URL that goes along with that page, and then also the code that we use to extract that first table. So let me just sort of run this, and I think I've loaded the, I didn't get all the code that I need here. So I'm gonna take here, maybe that works. Couldn't find function drug use HTML. I don't need this, sorry. So this, I had previously had code, one line that read in the HTML, and then this table started by taking that HTML and extracting some nodes. Here I'm reading in the URL to get the HTML and passing that directly into the next function. So like fingers crossed that this works. All right, so now I have this table for marijuana use in the last year, and I've done some amount of work on this already to extract to remove the first line that was just the note at the bottom based on reading things in from HTML. Okay, so if this doesn't make a lot of sense so far, try to revisit maybe the video that has to do with reading data from the web and this section. Today I'm mostly going to take this as a given, and now I'm going to try to do something that operates on this table. All right, so I think it may not be entirely clear at the outset, but actually there are some issues here. And the issues that I have with this first are that I don't really want these p-values floating around. As much as I trust the NSDUH folks to get this right, that's just not something that I'm interested in now. I want the prevalences. The other issue that I have with this is that the prevalences include superscripts, include extra information, characters that say something in the actual the table. They tell you something about what might be going on with respect to this prevalence. I don't want to worry about those characters. I just want the prevalences. And then the other things that are bothering me are that here actually in the columns I have a variety of variables floating around. So I actually have age range here, age 12 plus and age 12 plus, and then I have age 12 to 17. So I've got age ranges. That's sort of one issue. And then the other issue is that I've got year, right? This is 12 plus 2013 to 2014 and 12 plus 2014 to 2015. So the data are organized in a way that I think make it easy for somebody to do some kind of quick visual comparison to just sort of side by side, what is the change in this age group from one to the next, but it's not actually a tidy data set. So I've got some work to do here. What I need to do, and this is, I think, a good example of where strings actually do show up and the kinds of work that you might need to do as a public health data scientist. So I'm gonna create a data set for this marijuana table, and instead of using, let's see, equals, I'm gonna start with my table, and the first thing that I'm gonna do here, just because it's easy at this step, I'm gonna get rid of all of the columns that I don't want. So let's select, and I want to remove everything that contains p space value. Now, I'm gonna pause just real briefly to say that this contains is doing something that's very similar to str detect, and I'm giving it an exact string here, so that it's sort of operating in the same way that a regular expression might work, but contains and starts with and ends with are often doing things that look like regular expressions or that look like string operations here. And they sort of masked it in a way that makes it a little bit more user-friendly, but hopefully now it's sort of clear to you like, oh, right, that's doing some string operation stuff. All right, so what this is going to give me is a new table that gets rid of everything. And now what I'm going to try to do, I'm really going to make, since I know this isn't tidy, I'm going to make this a column, or sorry, I'm going to make my column titles a variable, and then I want whatever ends up in these cells to be sort of the prevalence that goes along with these things. So let's try to do this. I'm going to pivot longer, and I can either specify, boy, if I tried 12 plus all the way down, I'm gonna pivot everything that isn't in the state column, right? That's sort of the column specification that I want. Everything that isn't state needs to be converted from wide to long, and the names are going to be a combination of age and year. So I'll just call this for now age year, and my values are going to be a percent or a prevalence. So let's take a look. If I run this, oh, sorry, values 2. All right, so this is starting to work out the way that I need it to. I've got state, total US, I've got age, 12 plus and 2013 to 2014, and 12 plus 2014 to 2015, and I've got the percentages that go along with both of those things. So now I've got a couple of additional things that I might need to do if I wanted to tidy this up. The first thing that I might do here is say, well, you know, percent really should be a numeric variable. I need to get rid of the A and the B and the C. And I also want to convert age year. I want to split out whatever the 12 plus and 12 to 17 and 18 to 25. I want to separate that from the actual age range here. So those are sort of the two things that I'm going to do. And I'm going to do this in the order of separating first, and then I'm going to have to do some updating to both age, or probably to year, and to percent. So I'll save that for like a second mutate thing. So let's talk about separate. All right, so the variable that I want to separate is age, and the columns that I want to separate this into are age, oh man, age and year. And the way that I want to do this separation is starting to get a little bit tricky, right? So we have previously used separate by saying I want to separate after, say, the 1, 2, 3 character. Separate by itself will try to do something reasonable. It will try to do something like, is there letters and numbers followed by an underscore followed by letters and numbers? And in that case, it'll find that underscore and it'll sort of separate. Often you can sort of hope that separate is going to do roughly the thing that you want it to. But what I have here for age year, like this is tough, right? If I don't do anything, I think this will guess. Yeah, separate, sorry, age year into this. It's giving me this expecting two pieces. It has no idea what to do. So I do have to be a little bit more specific about what to separate. And the way that I'm going to separate in age year is to find the open parentheses. That's the trick that I'm going to use here. I'm going to find this open parentheses, and that's going to be the thing that I want. All right, so this separate, I need to find and separate at the open parentheses. Oh, that's not going to work either. Invalid regular expression, open parentheses, because parentheses is one of those special things in a regular expression. So I've got to use a backslash to say this is actually a parentheses, and I have to use another one to say this is actually a backslash, right? So now hopefully what I end up with after all of that is 12 plus, yes, 12 to 17, yes, and it has separated right there to get rid of that character, I think. Separate. So it's got remove equals true. Let's say remove equals false for now. Sorry. So that remove, oh, nope, that's the wrong one. What's happening here with separate is that it's finding that separation character and splitting it apart at that character and sort of getting rid of the separation thing that goes along with this. And I thought maybe remove was going to keep that open parentheses, and instead it just sort of keeps other things instead. So all right, this is what we end up with. Okay, we've got age, we've got year, and it's trimmed off all of those open parentheses. So let's now update some things. Ooh. getting back into mutate here. And the two things that I want to address here are the A and B and C in my percent. And it really bothers me that I've got this trailing close parentheses. So that's what I'm going to address first. Let's say year. Let's look for str replace in my year vector. So we're starting to see here where you can use these string operations inside of a data frame, right? So here, I guess up above, we had used str detect and str replace on a string vector. Now I'm using that str replace still on a string observation. I'm still operating on year, but I'm doing this inside of a mutate statement. I'm doing this inside of a data frame so that rather than just changing a vector in my workspace, I'm updating a variable in my data set. So I want to str replace in year. The pattern that I want to detect is the same kind of thing where I've got a closed parentheses, and I want to replace this with just nothing, right? So what hopefully will happen here is that mutate will update the year variable, and the way that it's updating that year variable is looking at it, finding this pattern, and replacing it with absolutely nothing, and that's what we get. So that's how you sort of trim that parentheses. We could probably, I'm not going to try to do this in real time, we could probably use str trim. We could probably do something in that way to just sort of cut off whatever the last character is, but fine, we found a solution. Next thing that I need to do is update percent, and I'm going to use the same process where I'm taking percent, and let's do str replace in percent. And now I'm going to be a little bit careful because I could sort of say I want to remove A or B or C. I could say I want to remove any letter anywhere that exists in percent. And the reason that I say I'm going to be a little bit careful is that my best understanding of this data set is that the characters that might exist are A to C, and I also think all of those should exist at the very end of a percent, so I'm going to put a $sign here. And the reason I say I'm being careful is this is, as far as I know, those are the only ways that characters should appear in this data set. And so I'm being specific about that because if I have some misunderstanding about how these characters appear in my data set, I want this code to break. I want it to not work if I'm getting something wrong about the data. But if I see an A, a B, or a C at the very end of my data set, I want to replace that with nothing. And as a next step here, I want to update percent to be numeric, as numeric percent. And that has worked. Percent, double character, all of this. Okay, so let's do just another last little thing here. Again, total US, and if I view this data set, total US, Northeast, Midwest, South, and West aren't actually states. So if I really just wanted the states, I'm going to need to do some filtering. So I'm going to filter, and let's say that I don't want my state variable to be one of either total US, Northeast, Midwest, South, or West. All right, that's the filtering step that I want to do here. Not state in. Oh, total US. You have to get your characters right. All right. This looks to be about right, I think. Okay. What am I pausing for? Let me just take a quick look. Alabama, Alaska. Okay. All right. That we'll sort of assume that this is about right. So okay. I'm going to continue on with this example just a little bit more, just again to sort of drive home how strings and factors actually show up in some of these examples. So let's sort of continue on with this data set real briefly, we'll see. So the next thing that I'm going to do is, let's see, I'm going to go ahead and knit. Okay, the next thing that I'm going to take a look at is same data set, NSDUH, and now I want to see how this plays out with factors. So let me take that same data set that I've just created here. Okay, and what I'm going to do is I'd like to make a plot that shows some of the things that's going on inside of this data set. So maybe what I'm going to do here is let's take a particular age group and let's filter. Age is in the 12 to 17 age group. That works. So here, age 12 to 17, Alabama, Alaska, Arizona, Arkansas, and so on. And I've got percentages for each of these 2 years. And so what I'd like to make here is some kind of a plot. And the plot that I'd like to make, let's just sort of say state on the x-axis and percent on the y-axis, and let's use year to indicate whether or let's use color to indicate the year range that I'm looking at. So that's sort of the plot that I like to make. And I'm going to do a ggplot here. And what did I say? State on the x-axis and percent on the y-axis and color according to year. And I'm going to make a geom point. Let's see what happens. All right, so, well, all right, a couple of things. The first is the labels are really just awful. And this is, it's going to take me just a second. ggplot theme axis labels. Let me do rotate also. Looks like I've clicked this one before. Yep, that's what I want. Let's try that. Perfect. Great. All right. So what do I like is what is still wrong with this? Well, state is in my data set a character variable, not a factor variable. And when I get to ggplot, ggplot has to know what order to put this in. So implicitly, ggplot is making state a factor. And when you do that conversion to a factor automatically, it's putting those in alphabetical order. So I've got Alabama, Alaska, Arizona, and so on. This is also, in this case, the order that things appear in my data set. This time, I'm pretty sure that's just a coincidence. It's because of the alphabetical ordering of state that we're ending up with this, okay? So what I'd like to do, though, is to put these in a slightly better order. Now, I've got a couple of options here. I guess I could do, let's take a look. I want to update state. And I can make this a factor first if I really wanted to, but everything in the forcats package is going to make sure that what gets exported is a factor, and most of them are fine with characters going in anyways. So let's play around with things. So I said I can do factor relevel, and the factor releveling that I want to do here is still updating a variable. I'm working on the state variable, and I can just sort of list what might come first. Let's say I wanted to list Texas first. Okay, so this bit of code, if I just run this, things are going to look pretty similar, right? It's still saying that I've got a data set, state, age, year, percent, Alabama, Alaska, Arizona, and so on. The difference between running that line of code, that mutate, and not, is that state is being converted from a factor variable to a character variable. And so here, when I do this factor releveling, I'm making Texas the default state. And so that's what I'm going to look at here. All right. Now this doesn't look like it's done all that much, but if I run all the code all together, it has moved Texas to be the very first state in this whole list. Okay, so you can do that. You can factor relevel a state or a couple of states if you want to. Let's do Texas and Oklahoma. So I can put Texas and Oklahoma first. I could play around with this. I chose Texas and Oklahoma because I grew up in Texas and Oklahoma is next door. So let's play around with this though. I don't want to have to like choose all of the states in a particular order. And so as I've said, what I'm going to try to do instead is use a different function in the forcats package. Instead of relevel, what I'd like to do is put state in order according to something that has to do with the actual prevalence that I observed. So here I'm going to do factor, not relevel, but factor reorder. And to do factor reordering effectively, I need to tell it what variable are you going to do that reordering in terms of. So here I'm going to do factor reorder. I want to put state in order according to percent. Right? So percent is the other variable in my data set, and I want to say whatever is sort of the lowest percent I want that to be my first observation. The next lowest percent should be the second factor, and so on. And since I've got multiple percent observations per state, factor reorder is going to take the median value of these and put things in order of terms of the median value. So let me run all of this. And what I'm left with is this sort of a plot. So it turns out Utah has the lowest median percent in 2013 and 2014. Iowa's next, Alabama, Mississippi, and so on. So now I've got plots that are in an order that I think makes a little bit more sense here, right? And that's I think enough on the NSDUH data set. So let me go ahead and play around. Let me go ahead and knit this. Okay, this is NSDUH factors. All right, on p8105.com, there's another fairly lengthy example of how you can work with strings and factors using a data set that comes from New York City. It's the New York City Restaurant Inspections data set, and what's nice about it is that there are some variables there that are pretty clearly strings and some variables that ought to pretty clearly be factors. I'm thinking for strings, things like the restaurant name, the type of food that's being served, and things like this. There are also some things that are pretty clearly factors. The borough, for example, where the restaurant exists is something that you might think of as a factor. And so I think it's a useful example to see how you can work with regular expressions and you can operate with strings and you can do things with factors, but it's a fairly it would take a while to work through in this video, and this video is already getting a little bit long. So rather than dealing with that, I'm just going to sort of say I encourage you to go and take a look at that code because I think it's useful. What I am going to do in the remaining couple of minutes that I have is revisit at least one data set that we've seen a few different times. So I'm going to take a look at the weather data set, and let me make sure I can find the weather data set real quickly. Let's say this is in visualization part 1. And I'm going to import the weather data set that we have seen a number of times in the past. Okay. And my weather data set now exists. Again, this is one that has shown up in a variety of videos. I've got the name of a weather station, Central Park, Waikiki, and Waterhole. I've got date, I've got precipitation, I've got Tmax and Tmin. So I'm going to do two things relatively quickly here. The first thing that I'm going to do is see how we have made plots in the past. So I'm going to real quickly revisit weather data frame, and let's do ggplot with name on the x-axis and Tmax on the y-axis. And let's do geom violin, okay? Okay, so this has created now the violin plot for Tmax. I've got Central Park, I've got Waikiki, and I've got Waterhole. Now we have in the past done a little bit of reordering here. For example, I've done a mutate to update, and when I say reordering, I mean of things that appear on the x-axis. So I've got Central Park, which starts as a character, Waikiki starts as a character, Waterhole starts as a character. To make this plot, ggplot is saying, I need this actually to be a factor with with numeric level 1 underneath. This is going to be a 2, and this is going to be a 3. That's sort of where this is coming from. And we've seen in passing how you can change that factor leveling, and I'm revisiting this just so that we're a little bit more clear of how this works now. So if I wanted to update name to be factor relevel name, not level, relevel name, I could make Waikiki Hawaii first, and then I'm going to get a data set that looks like this. Now again, what's happened here is I've sort of said very explicitly, make this a factor, it converts it to a factor in alphabetical order, and then I am shifting things around so that this is the first level in my data set. If instead of using relevel I wanted to do something like reorder, I can put this in order. I can put name in order according to something else that exists in my data set, and since I'm making a plot of Tmax, I'm going to put this in order according to Tmax. And what factor reorder does is it says, okay, what is the median Tmax for Central Park? What's the median Tmax for Waikiki? What's the median Tmax for Waterhole? And then we put things in order according to that median Tmax in each of those groups. And I get this ordering. So Waterhole has the lowest, Central Park is next, and Waikiki is next. And that's a useful way to go about creating, updating the plots in a way that you want to see. And it's the same basic process that we used when we created this plot, was starting with a character, converting it to a factor, and then updating the orders to be something that looks a little bit more clear. And just for the sake of argument, let's do one last example here. Ooh, I forgot, before we do that last example, I do want to mention one other thing in the weather data set. Now this point, I worry is going to be a little bit out there. And what I mean by that is, if you haven't spent much time doing linear modeling in R, then this might not make any sense at all. And I'll try to be clear about the point that I think is important here if you haven't done linear regression modeling, and you can sort of stick this in the back of your mind until it makes a little bit more sense. So if I wanted to do in a linear regression, let's just say fit a linear model where Tmax is my outcome, and I want to use weather station name as a predictor, and I'm using the same data set that I'm sort of have piped in here. It's going to fit, should fit. Oh, not df, data. Okay, so this is going to fit a linear regression, and if this doesn't make a lot of sense, that's fine. This is going to fit a linear regression that fits an intercept and then gives me a Waikiki coefficient and a Waterhole coefficient. And you'll notice that there isn't a Central Park coefficient here. And the reason that there isn't a Central Park coefficient is that Central Park is taken to be the reference group. So you compare Waikiki to the reference group and Waterhole to the reference group. And again, what's happening is that to establish these predictors, R needs to know the reference group, and to know the reference group, the predictor has to be a factor variable, not a character variable. So R is saying, you've given me a character, I'm converting that to a factor, and the factors are going to be in alphabetical order because you haven't told me to do anything else. So if I change this, for example, by updating my data set to reorder things according to Tmax, I'm going to get the same sort of a thing happen as I did in the plot that I made, where instead of having Central Park as the reference group, now Waterhole is the reference group, and Central Park gets compared to the reference, Waikiki gets compared to the reference. So again, the point here is I don't want you to leave this video thinking that the only way that factors matter is because it makes your plots look nicer. Really, when you start doing statistics, when you start fitting models, understanding what that reference group is and being able to change it to suit your needs is actually a pretty important thing. And I had sort of started to do another example here, and I think given the amount of time that this video is already going to look at, I'm going to skip that example. There are a couple of others, again, that exist on P8105. Take a look. I think it might be useful to sort of flesh out or see some additional examples of strings and factors. But I think in the interest of time, we're gonna call it here.